Thank you all for joining us. It is time to start our presentation, and we've had quite a lot of people jump on here. So this is Bill Murphy, your host, ASP Enterprises, Quick Supply Company, Bowman Construction Supply, and Cascade Geosynthetics. We are your trusted site solutions provider. So as you look at that little video that's inset, for those of you that got on early, I said that's something that Tyler sent to me via text yesterday from a project in Colorado he will talk about in his presentation. And it's just a tiny little snippet of what this solution can do, but it's super impressive. I am Bill Murphy. I am your host. I am the civil engineer for the four companies I keep mentioning. We have over 45 years of experience in the industry. ASP Enterprises is celebrating their 45th anniversary this year. Parent company, Quick Supply Company, has been around a long time. I always joke that I leave that 9,000 customers on this slide, that it should be 12,000 customers. Well, that's growing. I don't walk around knowing the number. I just know it's a lot, over 12 states and beyond. And we have a number of CPESC on staff. We are experts at erosion and sediment control and vegetated solutions. Our sales professionals very rarely need my help with those types of solutions, but I'm always here to help all of them. Half my job is technical support, helping our sales team. The other half is promotion and getting the word out about education, about the new innovative solutions that we didn't learn about in college. This world is ever changing, and we are keeping up with it. As I like to say, we are the tip of the spear. There's a map of our locations. We have the same map that's color coded with our different company logos. Fact is, we're all one company. You know us locally by the individual names because we didn't change who we are in our relationships. Here's all of our websites. Truth be told, the shortest one is aspent.com, and that will get you to all of them. We try to keep that updated, but you folks who have your own website know it's nearly impossible with the way things continue to evolve. So I'm going to share Muscle-Wall's webinar or website address at the end of this presentation. Tyler will talk about it as well. But you know us from any of these industries. Most of you may not know we're in all of these industries and even more. I focus mostly on the one in the upper right, stormwater management, but I can help with all of them. And I do the engineering technical side, but we are experts at logistics. We're experts at receiving containers full, truckloads of materials, and breaking that down to special orders to exactly what you need on your job site when you need it. We are trucking experts. We're inventory, logistics, sales experts, all those things that I'm not. I'm an engineer. I could drive a truck, but not legally. So we're ready to help you with your solution. I love to talk about the water cycle. I just got off of a national conference this morning where I was able to talk about some green infrastructure, and we are just a tiny piece of the global spectrum there for water. And one of the speakers this morning said that fresh water, stormwater, if you will, all together is about 2 teaspoons out of a gallon full of water that would make up the global water on the earth. So that sounds like a little bit, but it's huge importance because we've got to do the best we can with that tiny little piece that says fresh water. And one of the most important things we can do is protect our soil and our environment from excessive water. My guest speaker today is Tyler Searle. Tyler is Muscle-Wall's technical sales engineer. He studied at Utah State University in Logan, Utah. He focused on hydraulic engineering and received a BS in civil engineering. Hey, shout out to my fellow civil engineers. He is a transportation erosion control supervisor certified through CDOT, Colorado DOT. He specializes in applications with environmental risk mitigation needs. He aims to use his engineering knowledge and project experience to create a paradigm shift towards a safer and more resilient project future. And with that, I took his name and his picture from his last slide and put it on this slide so you can put your hands together. Help me welcome the one and only Tyler Searle. Tyler, are you with us?
Bill, that is too good.
Oh, all right, buddy. There you go. I'm going to hand over remote controls to you, awesome. And you're going to drive the bus as soon as you click on that screen. Don't you get that kind of welcome everywhere you go?
I wish I did.
Oh, you should.
I wish I did. All right, let's see here.
I think you're driving. There you go, buddy. Good luck.
Okay.
Holler if you need me.
All right, appreciate it. Okay, guys, so like Bill did kindly introduce me, I'm Tyler with Muscle-Wall. Super stoked to get on the call today with everyone and introduce our system and then follow up with questions and see where we can go with the conversation. But we'll get rolling today just for an overview of how the presentation will go. I'll just briefly introduce the system. We'll go over the logistics, kind of the engineering side of the system, and then we'll move into 3 separate subjects, flood control, containment, and then stormwater and erosion towards the end. Really just showing the versatility of our system in those different applications for some examples. And then afterwards, absolutely happy to jump into a Q&A session. Okay, we have just a few short videos throughout this presentation. I'll let them play through. As we get through, sorry, I'll just let the videos play through and then we'll jump into the details on the back end. And just a few short videos throughout the presentation, but I think they really show some valuable insight into the system being used on site and in live applications. Okay, so I'd love to start with that video because it really quickly shows the versatility behind our system. It shows how it's at its core idea, what it is it's just a mobile reusable retention device. And so right here, I'm just showing a variety of heights. We have walls starting with our 6-inch drive over system and then moving all the way up in height to our 8-foot and 6-foot height. And just a key note, all of these walls are designed to be deployed and mobilized by manpower alone and without the aid of heavy machinery, even at our 6-foot and 8-foot height. And only at these extra 6-foot and 8-foot heights is this exoskeleton angle bracing required. The other walls are designed as is, so they have a toe that's proportional to the height of that wall. And again, the idea is that all these walls are designed to retain. That's what they're engineered for. This is really the secret sauce in the engineering behind our system and what makes it an engineered solution. And the idea is right there in the toe. So the idea with the system is that as that risk force pushes against our system, it pushes pressure onto the toe to actually help anchor the wall in place. And so a couple key ideas really quickly. The system as it is, it's actually a hollow LDPE material. And so the idea is that it's really lightweight and easy to mobilize and transport. And then when you're on location, you can fill these walls with water. And so there's a port cap on the top side and then a bump plug on the bottom side for facilitating that water flow. But again, that's the engineering behind the system, is that as that risk force pushes against the wall, it pushes pressure onto the toe to anchor it. And then with that, in the company of a liner and water filling the system, that's how we complete the system and add the extra strength. And as I get into some of the pictures and applications, it'll make a lot more sense, but that's just kind of the idea. This just shows how the walls stack and are inverted. And then this just shows how our system is stored and transported. And this is a key asset with the muscle wall system, especially when we're competing against sandbags, rock gabing systems, concrete barriers, what have you. A key asset of our system is that essentially we're shipping air when we're mobilizing the product. And so just for a quick number comparison, again, engineering, I like to draw the engineering number comparisons, but one fully loaded semi-truck can hold, of our 2-foot system, can hold over 1,500 linear feet of that 2-foot barrier. If you're looking at doing a similar project with 1,500 linear feet of barrier for rock or sand solutions, materials, you'd be at over 41 semi-trucks just in material alone. Really quickly, you can imagine the logistics behind that and the difference of logistics and costs of shipping, and also the toll on the infrastructure for that municipality or what have you. And then I'll let this video
Begin
play.
by setting your first wall in place, and then subsequently sliding each 6-foot section in place using a coupler joint connection on the end of each wall. Once a section of walls have been set into place, you'll want to begin filling each unit. Insert safety ratchet straps through the kisters. With the 2-foot muscle wall, only 1 strap is used. With the 4-foot muscle wall, 2 straps are going to be used. 1 through the middle of the wall and 1 at the top. At this time, only secure the top strap on the 4-foot wall. The liner is then deployed over the muscle wall system. On the back side of the system, cut a small horizontal slit in the liner. Pull the non-ratcheted strap through the slits and then tightly secure them down.
Okay. So that's essentially our SOP video.
Begin by setting your first
All right, let me jump ahead to the next slide here and go back one. So what I just showed though was our SOP video. That's how we deploy our system. Essentially, it's those 4 simple steps. You drop the wall in place, you fill the wall with water to match your risk, and then you attach liner and straps. Depending on your application, there'll be some versatility in how you can attach a liner to complete the system. Just for some quick notes though, the system as it's designed has heavy UV inhibitors. So it has a 12-year UV warranty, and they're designed to last decades of use out in the sun. With that said though, oftentimes we're deploying our system with a liner, either an impermeable liner for flood control or containment, or a geotextile type liner where we're letting that water filter through and then capturing that sediment erosion for the stormwater space. And with that said, with those liners, oftentimes those will also have UV resistance, and that's how we can expect decades of use out of our system. Is essentially, even when it's stored outside, it's still being stored indoors, and it can only deteriorate through UV deterioration. Moving forward a little bit, I'm just about done with the logistical and engineering side. Bear with me, guys. I know this is just kind of tedious a little bit, but we're going to get into the pictures and applications, and it'll make a lot more sense. Really quickly, though, I wanted to show that our walls can interlock and connect at these different heights. So right here, we're starting with a 6-inch wall on the front side, drive over wall, then moving to our 2-foot, 3-foot, 4-foot, and then 6-foot wall on the back side. This is for a refinery down in Houston where they wanted to have a sloped refinery to have a wash station, a sloped wash station. But more importantly, on the flood control or the stormwater side, oftentimes that highest risk point is going to be at your lowest elevation point. And so we'll help the customers mitigate that by being able to seamlessly transition to these higher walls and higher heights without significantly widening out your base space. We are a vertical retention solution. And then this shows our walls actually being dropped into place by manpower alone without heavy machinery. This is our 6-inch drive-over system for wash stations, site containment. That's our 2-foot high, 6-foot wide muscle wall system. And that's our 4-foot high wall. As you can see, it has that LDPE play. So it's lightweight, it's mobile, they're able to drop it into place, but then it also has that malleability to it. It's not a rigid system, so it does have some flex to work with being dropped into place and work with the dynamics of pressures. And then I'm finishing up the overview and logistical side here, but again, I just wanted to bring up the idea that at the core of our solutions, what we do is we design and have engineered retention devices. And so they're used in a variety of different spaces, flood control, stormwater, and then containment and erosion as well. And we'll dive into some of these specific details as we get going into the presentation. Okay, so I'm gonna just jump right into some applications. This is where it's gonna be a lot of fun. And several of these we've worked with Bowman and the ASB Quick Supply Cascade team. And so I'll point out those projects. Specifically, this project right here is a Bowman project where they helped us out. And this is a stream diversion over in Colorado. So that's that intro video where you're seeing that stream diversion really at peak flow. This is that same stream diversion when we deployed it 2 months ago, over 2 months ago at this point. And so essentially, again, our system is a mobile retention device. And so it can be used to divert flow, control flow, capture it, what have you. And so right here, we're looking at doing a stream diversion. Originally, they were looking at pipe options, concrete jersey barrier options, what have you, and then staging the river so that they would pull the river to one side and then pull it to the other side so they could replace those abutments and the bridge. And ultimately, we got in there and decided that we could use our system and save them some staging and just divert that entire stream through our channel. And do a 4-foot channel right here. And so essentially what we did is we lowered the walls into place. Again, they're hollow walls. And so we floated them upstream, kind of teed in the corner units or towed in the front walls, just sunk those into place. And then one by one filled each wall and dropped them into place. And then our last step was to attach that liner, making it impermeable and just capturing all of that water. And then here's some pictures from that project. Again, showing the system being towed in on the front side and then working down that slope one wall at a time. And then what we did is we essentially staged it so that we staged the liner over the channel and then attached the liner and dropped it in right in front of the walls at the infall of the stream. And then just another picture, that's the same stream diversion, just doing a fantastic job. And just one of our key applications. And just a note, total deployment time with a team of 4 was 7 hours. And that included everything from unloading the semi-truck, staging the site, moving a couple of rocks just to get a relatively flat surface. Our system does work well with working with the topography and working around obstacles. But in some cases, we had to get in there and just move a few rocks that were in the way, just to flatten it out a little bit. And then just one of our last pictures right here. At this point, they've gone in there and they've actually deployed new riprap and abutments. And now they've got a new bridge in that they just installed towards the end of last week. But again, one of those situations where they're really constrained on the real estate and the amount of space that they had to work with. And so they essentially made a Venturi weir with our 4-foot walls and just channeled all of that water throughout the section. But a really fun project that we worked on with Bowman. And then this is another project that we worked on through Bowman and with the Colorado DOT and Kramer Construction as well. But this is right off of I25. And essentially what was going on is they've got an outfall where they have 5 acres of snow melt that all collects in one area. And so their traditional BMPs were just getting blown out. So they gave us a call. They had this emergency situation where they had crews out there day in, day out, just wrestling this section and continuously trying to reset BMPs as they failed. And so they called us up, said it was an emergency situation, and we immediately got in there and deployed our 4-foot and 3-foot walls to have a weir type basin for their swale. And since then, it's been working fantastic. They've had these weirs in place for about 2 months now, and it's just completely eliminated their risk in this area. They haven't had to revisit it since. And then moving forward a little bit, I'm going to just dive into stormwater. I'm going to dive into a few of our different applications and recent case studies. And then after that, we'll hit containment. And then towards the end, I'll just briefly touch on flood control, just again, showing the full versatility of the system. But on the stormwater side, this is a really fun project. This is actually over on the West Coast. This is Treasure Island. And they're using our system as one of their key BMPs. And essentially, we're dealing with really steep slopes. And their traditional BMPs, hay wattles, silt fences, they just weren't able to keep up with everything. And so the engineers went in there and they spec'd in muscle wall to appropriately match that risk, to appropriately defend against that risk. And essentially what happened is the crews just went in there. They just had the construction crew go in and actually just drop the walls into place on the hillside and then fill them with a hose. Again, they didn't have that mobility that they needed to get K-rails and stronger solutions onto the hillside. But at the same time, right, really high regulatory space. If they had any failures, this project would have been at risk of failing or, at the very least, really significant fines. And so we got in there and just completely shut down their risk. We're really a robust, strong BMP solution where it's one of those solutions where it might not fit into every project and every need, but certainly in those areas where you have high risk, and high debris flows, erosion, things like that. That's where we're an excellent solution to match that higher risk. And then we'll just walk through a couple of these pictures right here. But again, on this hillside, these are same pictures from that project that I was just showing a bird's eye view. But essentially, they were dealing with 15 to 50% grades on that hillside. And so what they did is they installed a series of 9 detention basins to help dissipate that energy flow moving down the hillside and just capture as much of that sediment as possible. And so you're really seeing all at the same time how the system does on hillsides with a steep slope, and then also being deployed, with varying terrain, working around rocks, gravel, soil, and then asphalt as well, being able to move with the terrain. And then also just a key note, we did have curved walls and straight walls. And essentially what that means is that at the juncture point, our curved walls have 11 degrees of rotation, forwards and backwards. And so that helps us create these basins or follow river lines or what have you. Just having that mobility, again, at each juncture point as well. And then a lot of fun. I'll just hit a couple key notes here. So this is actually one of the largest stormwater projects currently in North America. It's the largest stormwater project west of the Mississippi. And essentially what's going on is they're using our system again as one of their key BMPs. And to the left side, we're seeing stage 1 of this project, which was the first couple of years where they're using our system right through Lions Canyon. And you can see Magic Mountain just barely in the background, so you guys know where this area is. But right there, you're seeing our system being used as a check dam, series of check dam weirs. We've got 10 of them in place. And essentially what they're doing is they're using our 4-foot walls and our 2-foot walls to, again, create that weir type shape. Really similar to how we did the CDOT project, but this is definitely an effective use for our system. And on that note, with DOTs and things like that, we do have special provisions with, for example, the Colorado DOT to use our system in replace of a rock check dam as an alternative to that for DOT projects, just because of the just huge leaps in ability to have a much faster deployment and then a lot lower maintenance throughout the course of the project. To maintain our systems, you just go through there and clean out that basin. You wouldn't have to pick up the rocks, filter them, everything like that, and then redeploy them. You just clean out the basin in front of the system, and then it's good to go again. And then super interesting, and this is a key note, our system is designed to dynamically shift throughout the stages of the project needs or to the next stage or the next project. And so these same walls that were being used as check dam weirs, now they've been moved to stage 2 of the project, and they're being used as a mobile and temporary channel. This channel is 3,000 linear feet long, and they're using our 4-foot system. Just a really fun application. Essentially, they had a huge on-stream or I'm blanking on the word here, but essentially they're using this to divert their stormwater throughout that site. But really cool application. And then essentially if they had a stronger storm event where they needed to allow for higher flow capacity and volume, they could just widen out one of the arms of this channel to allow for that higher flow rate. Another great application. And just a side note here, we're seeing 2 different liners being used. To the right-hand side, that's where they just wrap those weirs where the geotextile, letting that water filter through the kiss-throughs, through the juncture points of the walls, and then seep over that 2-foot weir. And then to the right side here, that's where they used an impermeable liner. And this is where we had a liner crew go out there and actually manufacture and custom design this liner on site as they went. But again, that's where you'd use an impermeable liner for that complete control. And then just a side note, we've been getting heavily invested in the post-fire space. And specifically right here, I've got a few projects that I'm showing, but we're currently working with the NRCS in California and Colorado, and we have current projects out with both groups for this year. And so to the right side, these are our projects over in Colorado, Rifle, Colorado specifically, but essentially they're using our system along river lines and in those high flow areas to help divert that flow around homes and key infrastructure pieces. And same exact idea on the West Coast over in California. But one of the notes is the California NRCS in their projects, they actually do not use a liner. They're just deploying the system as is without a liner, and they're looking for that 95% control where they're being able to divert that debris flow around the key infrastructure piece, but then they're expecting to have minimal seepage, and that's okay. They just want to, again, have control of the majority of that flow. And then just some finish up pictures right here, just a few more pictures to round out the idea of how our system can be used in a wide variety of ways in the construction and stormwater space, both again as a B&P solution for check dam weirs, also for channeling, and then certainly stockpile containment, whether it be stockpile containment for soils or also containment for fluids. Again, our system is engineered to retain and hold that. And then I'll switch gears briefly. I've just got a few slides on the containment side and then a few slides on the flood side. And then again, we'll kind of finish up and wrap up the ideas here. But just showing our same walls in a different space right here. This is our system being used in the containment space, both for primary and secondary containment. And so just a couple of notes here. On the bottom side, we're actually looking at a 6-inch drive-over system being gapped with our utility crossover bridge. And so our 6-inch system is actually just kind of a unique animal. It can be deployed a number of ways, and we're seeing 4 separate ways right here where we're seeing a single-sided stockpile containment. This is actually for Kramer Construction and CDOT on their I25 project. And then drive-over containment, where we have 2 walls back to back, and the liner going over one and under the other, and an underclip holding them together. This is oftentimes perfect application for site containment, oil and gas side, or utility space. And then also, again, showing our crossover by bridging that gap for the drive-over system. And then showing our system being used for AST ponds. This is actually for midstream operations for oil and gas, but it's showing 2 ponds that we set up with our 4-foot system. And again, mobility and the lack of logistic needs. So right here, they set up these 2 ponds in a total of 10.5 hours. And that was a brand new crew. They'd never seen our system before. You know, it was one of those things where we went out there and we trained the crew and we kind of oversaw this deployment. But in total, they were able to get both ponds up in 10.5 hours, 7 hours for the first pond, and then half that for the second pond as they became more familiar. But that's really the key idea, is that mobility. And then I'm going to shift gears again, and I'm just briefly going to introduce how our system is used in the flood control space. This is, again, a totally different animal, but our system has been heavily used in the flood space over the last 12 plus years. And so I'll dive into some of these details, but just really quickly, a key note is that we have been U.S. Army Corps tested and FM, ASF, PM approval tested and approved. And I do have that same, or I do have the full testing report from the U.S. Army Corps for the FM and ASF PM testing. But really, that's a key note. That's the top tier test for flood control in the United States. And we just finished that up last spring. And I'll be able to share a short video clip of that testing in this presentation. Okay, so I'll pause it just for a second. But again, this is our Army Corps testing. So it's just a minute snip of that testing. And I'll talk over the testing as we go. But again, key video here. Okay, so essentially what happened is they did a variety of tests over a 10-day period, simulating, sorry, let me play this again. Simulating a variety of flood type situations though, where they had a hydrostatic load test, they had debris impact, current flows, overtopping the system, and then also wave impacts as well. Overall, we did successfully complete all of the U.S. Army Corps testing. And not only did we complete all their testing, but we tested best in class. So for our class, we're the only solution to pass all of their tests at a 4-foot height. And we're directly comparing against sandbags, HESCO barriers, and typical flood solutions. And what is also useful is that we can directly compare our system against the other systems that have been Army Corps tested and approved. It's the same report, and then that way you can, apples to apples, see how our system compared and came ahead. And that's the debris impact test, again, showing how that LDPE material comes into play, being able to take on debris impacts and dynamic flows without fracturing or breaking. Okay, and then just a couple notes here. I actually pulled this directly from that Army Corps report. And so this is just showing our system directly compared against their standard of sandbags. And so we certainly had a much faster deployment time, 7.5 hours compared to over 200 hours. That's definitely expected. But I think more importantly, what I want to draw attention to is that we had no maintenance throughout that entire testing period. Whereas the sandbags repeatedly had maintenance throughout the testing over that 10-day period to be able to maintain their system. And that's a key idea though, is that our system is designed so that if it's deployed per SOP, it's designed so that there's little to zero maintenance that would need to be done. And that's definitely key on the flood side, because if that maintenance is not kept up, eventually they're at risk of a catastrophic failure and of the system failing altogether. And then again, just a side note, we also had a 4 times greater or lower seepage rate. And then just directly comparing, sandbags are still the #1 flood fighting solution in the United States, which is just crazy. But really what we're trying to do is we're trying to bring a more sustainable and innovative solution to the market. And so we'll immediately save on real estate space, at deployment time, and also being a safer solution, but then also costs comparison at the end of the day. What we found, and the Army Corps has found, is that when the actual true cost of the sandbags is considered with the material costs, the logistics of transporting the materials, labor to actually deploy the system, and then also all the logistics to remove of the system after it's deteriorated, with all of that considered, oftentimes we're as cost effective, if not more cost effective, on that very first deployment. And then again, having that reusability and all those valuable points of the Muswell system, and being able to versatilely use it in other spaces as well, not just flood control. And then on the flood note side, just to kind of showcase what we're about, this was just about 2 weeks ago. We went out to Portland and helped Cascade Geo with this demo for the Water District and the City of Portland, showing our system and how it could be used as a flood defense system for the City of Portland. But this is one of those things where we'll go out there, we'll train any customers, anyone who's interested in learning more, we'll go out there and train them, we'll oversee that first deployment, and we'll offer that business support throughout the process. And then on the flood side, I really just want to kind of hit 2 notes of how our system's used. I think it really breaks down into 2 categories, at least in my mind. And the first one is freeboard or diversion is how our system's used. So it's used to divert that flow, or as a freeboard solution for channels, levees, river embankments, what have you, any application where you might need that extra freeboard. And then again, also in that middle bottom picture, showing a diversion. And this is a key idea with our system, is that it is a perfect application for any wetland or marsh projects or stream projects where you already have water on site. That's not an issue with our product. As long as the water is shallower than the height of our system, we can actually float our wall into place and then sink it into place, attach that liner, and then trash pump the water from the backside over to the front side or the wet side of the system. But that's how we do those stream diversions or cofferdam type applications, wetland projects, what have you. And then on the other side, flip side of flood control, definitely perimeter control is a key space for us, not only for infrastructure pieces, downtown areas, but also closing off those egress areas to have an effective community-based flood plan in place. And then I do want to just key in on a couple of these pictures of our system being used for perimeter controls for utilities around the country. But a couple ideas here. One, in the top right picture, you're seeing our system teed in to this flood wall right here. And this is actually for Passaic Valley Sewage up in the Northeast. And essentially, this is their first line of defense for their seawall against those nor'easters. And so with those waves and the expected storm surges, they just really felt like this wall specifically would be at high risk. And so what they did is they just teed in 4 of our 4-foot walls filled with water to add the extra column support on the backside, just to give extra support with those storm surges. And then also showing in the bottom middle picture, showing our system hopping over a curb. Just a side note, but at each juncture point, the walls can shift. So they can shift vertically to hop over curbs or work with the topography as you need it to. But again, just showing our system in a few different ways here and showing it with the liner and without the liner. Oftentimes they'll deploy it without liner for flood control if they're going to leave it up semi-permanently, just with egress areas set to the side. And then they'll just deploy the liner as need be, depending on the UV resistance of that liner. And then coastal erosion. I know, and I definitely recognize I've been moving fast as we're kind of moving through these topics, but I just really wanted to show some of the versatility of the system and how it can be used. And so just another note, our system definitely is an effective solution in the coastal erosion and intercoastal play being used for erosion control. And essentially what's going on right here is they're having our walls with the toe facing the buildings. And so our walls are acting to retain that beachhead. And we actually have 2 tiers of our 4-foot system in this picture. That first tier is almost being completely overtaken by this wave. But essentially we're doing 8 feet of effective seawall by tiering the 4-foot wall and just wrapping it with a geotextile. So as these waves crash into the backside, the waves are dissipated, the energy is, and then as the waves come up and over and carry that sand with them, the water is able to filter back out to the lake or ocean, and then they're able to retain all that sand and capture that beachhead. What's super unique about this though is that we're one of the only solutions that you can actually actively build up your beachhead with. So over the years, you can actually move this wall out towards the lake or towards the water to restore that beachhead that you originally had. And then just to kind of round out the idea, again, the system's deployed as is, and then attaching a liner is oftentimes how we complete the system. And attaching liner is sometimes the trickier part of the system, but this is where we just talk through your options, talk through whether or not you can break the subgrade, what kind of seepage rates you're looking to achieve, all these different variables, and then we'll make sure that we have a viable liner option for you, and depending on the surface as well, whether it be concrete, soil, asphalt, what have you. And then this is some of our early testing. This was testing done with the USU Water Lab and the US Army Corps of Engineers. Essentially what we did is we simulated a flash flood type situation, just releasing that storage of water and letting it gain some momentum as it goes down the hill and then just crashing into our 4-foot barrier right there. And again, a few key notes. You're seeing that a bend at the juncture point so that we can create this basin shape. You're also seeing that the system has no metal components on the backside. There's no stakes. There's no metal components on the backside. The walls are just dropped into place in that instant that that water or the material hits our system. In that instant, it's acting to help put pressure on the toe to hold the wall in place. And so our system does do well with dynamic flows or flash flood type events. Okay, and then I know I moved fast. I just wanted to, I guess, fall in on a couple more just key ideas here. Again, the system's just a mobile retention device. And so it's designed to retain, it's designed to be mobile, and then you can fill it with water on location to add the extra weight and strength. And then each wall is designed so that it has a toe proportional to the height of that wall. So each wall is designed to retain at that height and even be overtopped without sliding, tipping, or failing in any way. And then last,
I unmuted myself. This is Bill again at 110. Excellent job, my man. I wish we had more time because I could listen to you all day. I'm going to get to the Q&A, but first I just want to reiterate a few things. Tyler said he was going fast to this information, and I think he did perfect on timing. I don't think it was too fast. What he's doing is piquing your interest. So we're just letting you know there's a lot more than just one application where muscle wall solves problems. And we are totally open to suggestions. In fact, these guys have so many more projects that they could have mentioned with different types of uses with muscle wall that we're just scratching the surface. So you see musclewall.com on there. Before I even click over to my next slide, I'll tell you that's right at the top of it. So we have not yet updated our websites with our muscle wall information, and they are excellent at sharing pictures and videos of successes and sharing information and answering questions. So keep that musclewall.com, write it down on your notebook if you're not taking very many notes. But before I get to the Q&A, I see 4 of them on there. We're good on time. I know that there's a long play here that we're very interested in, and that is flood protection, and that takes a while. So some of those things take years to develop. I mentioned to these guys, I live in Iowa, for those of you that don't know. We're heavy with ASP and Quick Supply in Iowa, Missouri, Nebraska, Kansas, or surrounding states, Illinois, Arkansas, Oklahoma. And they've already had success. And right now, these 2 guys are out in Cascade Geo's territory in Oregon. And they've done some projects, which Tyler shared with you in Colorado for our Bowman Construction Supply already. I'm amped to get them rolling in the Midwest. They have some projects already in the Midwest. These are some folks that have been working hard on their systems and their relationships for a few years. And as George Duyson, who's on this call, would say, we're looking for the collision where 45 years of ASP and Quick Supply and our partnerships collide with the efforts of Muscle Wall. So the long play, the long-term goals for flood protection take a while to develop. You know, you go through the admin of FEMA and the action of the Army Corps. They've already done the most important part, which is Army Corps testing. I personally am asking anybody on this call, if you or someone you know is related to the effort of the 3 governors from Iowa, Nebraska, and Missouri, where the Missouri River is flooded several times in recent years, contact me. I'm very serious about getting that going. I have some of my own contacts. I want to intersect them with your contacts. And with that, I see 5 Q&As. Let's go to the first in order. Tyler, I'm going to take over control. The first Q we were asked was if we wanted to use it to isolate dirty water from clean water, would it stay down when immersed with just a few inches on the top? If there's only water on one side and dry on the other, would it stay up? So does it take a lot of inches to hold the product in place?
Yeah, so great question. So no, it doesn't. That's not so much the issue. The only issue would be that you have to have, you can't have equal amounts of water on each side that are at the height of the wall. So if you had a 4-foot wall and you have 4 foot of water on each side, then you would have issues. But as long as you have lower than 4 feet of water and you can pump from the dry side over to the wet side, then you're okay. At any height of water, you're okay.
Thank you. On stream diversion, how do they release the existing stream into the diversion without creating sheet flow underneath the diversion? And that's an exciting story at Manitou Springs when you walked that liner down. How did you do that?
Yeah, Jeremy, so great question. So it was actually pretty unique. So what we did is we first staged the liner over the entire channel. Essentially, we opened it up like an umbrella, staged it over the outside of the channel, and almost like bridging it over the gap. And then what we did is we started at the back side, and using our liner clips, we actually walked up the sides of the walls. And so what you do is you actually walk on the toe of the wall, and essentially what you're doing is you're hugging that liner down against the wall. You just don't want any void spaces with the liner. So as you start from the back, you're walking that liner in on each side. So we had one person on each side of the channel walking it in. And then as we walked up the channel, we started attaching liner clips, staging that liner. And then once we got to the very front, it was all hands on deck. We had 3 or 4 people grab the front of the liner. And in 1 second, we just quickly tucked it underneath that stream. So at this point, we'd been walking on top of the liner, on top of the stream bed. So essentially the liner is about 1.5 feet above the ground on water. So we're walking on the liner on the water. And then as soon as we got to the front, we just keyed in. And in that second that all of us put our hands under, I mean, it was a snap of a finger and the diversion was done. All the water flowed into the diversion and flowed out the backside, and then we were done. And so all we did just to tow in that liner on the front side is we just put a layer of rocks just on the front 2 feet of that liner. And it's been in place for over 2 months now with those peak flows.
And that's that project where I showed that little tiny clip that you sent me, 8-second clip on the cell phone, where there's an outrageously fast, steep flow going through it. And your product is doing awesome.
Yeah, yep. That's the entire Manitou stream is being diverted through our system in that section right there. And so typically it's a 15, 20 foot wide stream, and it's just almost acting like a Venturi weir, pushing it through our system right through that little channel
It's
section.
amazing. I was just out in Colorado 2 weeks ago, and everything in Manitou Springs area is steep, narrow, and fast. And you were a perfect solution. Angela Grote has 2 questions back to back. Are you aware if muscle wall has been used in the contingency environments, for example, Army bases, and can it be filled with anything besides water?
Yeah, great questions, Angela. So off the top of my head, I can't think of anything off the top of my head as far as on the Army base side. With that said, we have had connections in the Army and with the Army Corps as well. Certainly with the Army Corps, that's where we're heavily invested, but not so much with Army bases. I don't have anything off the top of my mind or the top of my head. And then
we will soon. I'm confident.
Oh yeah. Oh, definitely. Especially as HESCO gets pushed out, sandbag solutions, as they look for more sustainable options. But Angela, for your second part of your question, can it be filled with anything besides water? It can. So one thing that we have done in the past is that we've filled it with, say, like a high density foam would be an option, or people have filled it with sand and different things. But with that note, that's where you'd be looking at more of like a permanent application if you're looking at filling it with anything besides water. Because as soon as you fill it with anything besides water, that's when you lose your mobility. And that's the key asset of the system, is that at any point you could drain that water and move that system, within a few hours, a day tops, to the next location. And so we like to have that water just for the mobility component, but essentially for the weight factor, we can look at other options if you're looking at a permanent application.
You're leading right up to the next question, or the question after next. But for right now, Donald, who attends all of our webinars, he asked how water is drained from the walls, and you may have shown it quickly. I've had the luxury of seeing a slower, longer presentation. And then what are the straps and buckles made of?
Yeah, great question, Donald. So just really quickly, we've got a port cap on the top side. It's a 3-inch diameter port cap, and then we've got a bump plug on the bottom side. That's how we facilitate that water flow. Oftentimes on site, we're just taking the water source that we're working with. And so, if we're dealing with flooding, we're taking that overtopping stream, we're taking a trash pump and just pumping that clean water into our system. And then at the end of the project, we'll just open the bump plugs and let that water flow back into the stream. And then to answer your question, Kent said, can you make it a permanent flood control solution, permanent liner options? And so yes is the short answer on that. Yes and no. So yes, though, what you'd do is you'd use a long-term liner that has 20 or even 40-year UV resistance. And then my experience in the permanent space, permanent quotation marks, good point right there. But the idea is that there still will be maintenance over the years. And so for most permanent applications, say lagoon or what have you, they're still required to go out there every 5 years to check on the system. And so especially with that, minor maintenance, we can definitely be bridged into the permanent space, and especially with a high UV resistant liner. Again, essentially, as long as our system is being protected from that UV, that's the only thing that can deteriorate our product. And so you can definitely, look for long-term deployments, and then even look at liner options down the road.
Yeah, you took my job of reading the questions out loud because you're super excited, Tyler. Now, what about the straps that you showed strapping the units together?
Yeah.
Is that something that's included, or is that something that they just buy what they can at a local hardware store?
No, great question. So our system is a turnkey type system. So anytime anyone were to purchase an order, they would have all the components necessary for their order within that order. And so just on your note of straps, what we do is the straps actually ship out on the inside of the wall. So when you take off that port cap, the straps are actually attached on the inside of that port cap. And so they'll ship with the walls on the inside of the walls. And that's just part of the cost of the material of the system. The only add-on that you could do is you can add on a liner clip that does the full length. It goes the full length of the wall on each side. And that's a 1/4-inch tension spring steel. That's a great option, definitely for permanent applications, or certainly applications where you might have wind, or if you want to stage it like we did for the stream diversion. But the straps do come with the system, and then liner clips could be an add-on.
Well, for the sake of time, I'm going to go back up because we did get to answer the questions. I'm going to read some notes from a meeting we just had recently, but I'm going to go back up to that very first slide. Let me take over here and get rid of Tyler's controls, just so I can show it. Oh, did you want to include that or no? The price list.
Fine. So that's our MSRP.
Okay, so you had that after your final slide. Why don't you talk through that?
Yeah, I mean, just really quickly, this is our pricing. So that's our 2-foot, 3-foot, 4-foot, and 8-foot costs. And that's our MSRP cost. So that's what you would pass over to your customer. If you are the customer, this would be your cost. And that's how it breaks down. Essentially what it is for our 4-foot system, we're just over $100 a linear foot. Our 2-foot system, we're just over $50 a linear foot. Again, anytime you're bringing up these costs though, it's an investment with Muswell. We're a versatile solution that's meant for long-term use, and then also saving on the logistical, maintenance, all those different aspects where we can save on cost. But we are a long-term investment for a versatile variety of different applications.
And I have some personal experience. I'll just show the final slide. I'm going to tell a personal story before I go back up to that very first slide of yours. I may have told you this briefly getting to know you. I do mission work all over the country and sometimes Central America. And a lot of the mission work I do is natural disasters. I've done hurricanes, tornadoes, floods, a lot of poverty missions. And every one of those natural disasters or poor situations are unfortunate and devastating. But I can tell you there's almost nothing worse than cleaning up flood debris. And hurricanes Katrina and Rita brought a lot of floods with them, especially Hurricane Katrina. When Slidell, Louisiana was inundated with a wall of water that came from Lake Pontchartrain, a lot of communities, including homes and churches, were devastated by massive flooding. And it wasn't the small, narrow, fast flooding you see here. It was just a wall of mud and muck and human waste that came in, and it's very hard to clean up. So if someone ever talks about sticker shock with something like muscle wall, wait until they lose a bridge in a case like this, where they didn't protect a pier well enough, or an end of a bridge, or some other structures downstream, or whether it be some other diversion near a dam when there's being projects being done. But if you start to talk about massive, large scale flooding, not only in private property, but large public features, it gets into the billions with a B, kids, billions. So it's hard to put a price on that kind of protection and risk management. There are people in the world that are very good at risk management. Most of us that went to college for civil engineering, Tyler, you can attest to this. We didn't learn that level of liability and responsibility for risk management, not in the billions.
Yeah.
We talked about erosion and sediment control. We talked about geotechnical engineering to protect building footings, houses, and some of us got into bridges that were structural. A lot of the people on this call are involved with roads in one way or another, but that large scale risk management is not going away. And in recent years, we've just seen it grow in responsibility. And while I'm not here to plug another firm, I did see the name of NGO on there, and we're talking about some people that you folks know that we could connect with, people here in the Midwest, out in the Rockies, in the Pacific Northwest, who can help the decision makers figure out what they've got to do with something that's been tested by the Army Corps of Engineers that can protect life and property. Do you want to touch on that just briefly, even though we don't have a slide for it?
Absolutely. No, I loved all those points. And just to piggyback off of what you were saying, and that's definitely really powerful. But on the flood note, definitely flood is a key market, and a key, I guess, asset of our system is the logistics side. And so oftentimes when I go into that conversation, first I'm getting an understanding of what their current plan is, whether it be a steel barrier, concrete barrier, sandbags, HESCO barriers, super sacks, what have you, water barriers. First, I get an understanding of what their actual plan is, and then we need to dive into, realistically, can their solution and plan be deployed in the timing and on an emergency situation? Will they have operations? Will they have machinery? All those different details. And that's where, where cost no longer matters. If at the end of the day, their system is not even a viable option, if they did have something catastrophic happen, that's where, we do need to have a system in there that has that mobility to be deployed without heavy machinery, without skilled labor, in just a day's time with volunteer work. That's definitely a key asset, just piggybacking off of what you just said.
Well, and one of the things that people here in my part of the world in the Midwest don't realize is how devastating, I'm going to turn the volume off on this if I can, how devastating, see if I can turn it off, the wildfires can be on an environment where they get tremendous flooding and movement of sediment. And I think that's part of what you're doing in the Pacific Northwest. You could talk about some of that fire mitigation again.
Absolutely. Yeah, absolutely. Working with the NRCS and using our system for erosion control, debris erosion control, and then also flows, overtopping rivers, overtopping channels, all those applications, both in Oregon, California, and Colorado. That's what our system's being used for. And then all of those areas were approved by the NRCS. We're a key solution for them. It's just a matter of going in there and bringing that exposure of our system.
It just seems like there's so many firms and communities that didn't used to have to deal with this stuff, these kind of tragedies and challenges, that do now. And like I said earlier, it's not going away. It's just going to continue to happen on a more frequent basis. Curtis has a question, a specific question. How many gallons? This is a tough one to answer because it's the area that's up against it. But how many gallons does it take to fill? I got you. No, it's very specific. To fill a 4-foot high section, 6 feet long.
Yeah, so that's the easy question. Thanks, Curtis. So that's almost 200 gallons. What it ends up being is it's almost 1,400 pounds. And I should go into those notes just really quickly.
Here, just take over if you want.
Yeah, sure.
I'll give it back to you, Tyler.
Thank you. I'll just go back to our overview slide with our different heights. Let's see here. Just to give you some points of reference for weight and things like that.
200 gallons, you said?
Yep, it's about 200 gallons for a 4-foot wall. It's a little bit less than that. It's closer to 175. Essentially, though, it's 1,400 pounds full for a 4-foot barrier. And then empty, it's 120 pounds. So just right here, just for a couple weight just notes. Our 4-foot wall empty is about 110 pounds. Our 3-foot wall is about 75 pounds. Then our 2-foot wall is about 50 pounds. And our 6-inch system is about 35 pounds. So heaviest wall would be our 8-foot system, but commonly used, our 4-foot wall is about 110 pounds. And when it's filled with water, our 4-foot wall is about 1,400 pounds. And so that's how we also use it as a column support, in areas with high risk.
I love it. That's fantastic. As a reminder, for those of you that didn't get your questions answered, you will have a chance to ask those later. I may have taken over from you, Tyler. It sometimes happens.
That's okay.
When I'm having to click around on participants. So we've got a lot of participants on this call. I think we got to all the questions and answers. We will share a recording of this, and with Muscle Wall's permission, we'll share a PDF of the presentation. So that'll be available so they can see this type of information. And we're also going to encourage more of you to reach out and ask for a personal meeting. And these guys are willing to travel. So George is in Utah and Tyler's in Colorado, but right now they're both in Oregon. So if it's something worthwhile and you want me to help set up a big meeting and we can go see a number of key decision makers, it doesn't have to be big. These guys are willing to travel wherever. The other cool thing they're going to do, I'm really excited about this. They're going to send demo kits to some of our locations so we can share those with all of our branches throughout our companies. And I'm not giving those away. I'm keeping those, but I'm going to do some on-site demonstrations where I'm going to take them around like a travel and road show. So will our sales team. We'll bring these to you, and you can try to arrange to have some people meet in your community. I would really love it if some of you city folks or some of you engineers that have good relationships with your cities or contractors want to host an event where we'll bring this system to you and show you how easy it is to handle. That's easy to do. So demo kits, we'll have those in a matter of weeks, right, or days?
Absolutely. Yeah, we'll get those over ASAP.
That's awesome. I think going hands-on is great because my guys made the mistake of calling this a Jersey barrier, and it's absolutely not. This is not something you got to pick up with a loader or an excavator. This has, it's not symmetrical. It's got one side where you can see through all these application photos, the water is going to help hold it down. This thing will not tumble. As an engineer, I love it. I vouch for it, or else I wouldn't have had you here today. So Tyler, Searle, you're awesome. I'm proud of you. George, thanks for being there. Good luck with your trip in Oregon. Any parting words for our friends before I close this out?
I appreciate it. And just lastly, just kind of parlaying and finishing up the idea, but really the system's half of what we bring to the table. Our knowledge, our project experience, the relationships we have with ASP, Quick Supply, everything like that, NGO as well. When we bring all of that to the table, that's how we're going to be able to close these jobs and really help support you guys. And so again, the product's just half of it. Our team is definitely the other half.
That's why you're a perfect fit for us. We solve problems. We help mitigate risk. So we're going to do it together. Thank you, guys. Take care.
Thank you. All right. Thanks, everyone.
Thank you all.